Hello everyone, how are you guys? I hope you are all well. Okay, let's start today's lesson, the chapter 8.3 and classifying quadrilaterals. As you know, we have the many types of quadrilaterals. One of them, for example, square, rectangle, and trapezium, or parallelogram, parallelogram, and blah blah blah. In this lesson, we will learn the types of quadrilaterals, and properties of these shapes. Okay, so let's read first of all. A quadrilateral is a 2D shape. Okay, because let's explain it. Why it has got two? It's the shape of 2D. Sorry, 2D because it has got only height and length. For example, let's take a rectangle. I'm sorry, it's a rectangle, okay? And it has got only area and perimeter, for example. For area, we need height and length. What was the area of this rectangle? Height times length. And that's why it's called 2D shape, and also square 2D, and trapezoid 2D, and a kite also 2D shapes. Okay, 2D shape with four straight sides. Four sides. It has got straight sides, and a diagonal is a line that joins two opposite corners of a quadrilateral. For example, what kind of shape this one is? Trapezoid. Am I right? So that's why uh, from this point to this point, when you draw the straight line, it's called diagonal. And here also we have diagonal. So we can say in quadrilateral shapes has got two diagonal sides, two diagonal straight lines. Every quadrilateral has two diagonals. The diagonals always cut or cross each other, and they are crossing each other. Okay, you can remember which letter? X. X. Okay. In some quadrilaterals, the diagonals bisect each other. What does it mean bisect? Please check your dictionary if you don't know. The word bisect means to cut in half. And I cut here this part and this part, divided two parts. Two parts, okay? So in a rectangle, the diagonals bisect each other. It's a rectangle. It's a rectangle. And so it has got also two diagonal lines and bisect each other. They bisect each other, letter X. And here also, what kind of shape? It's kite. In a kite, only one diagonal bisect each other because these two sides are equal to each other, but these two sides are not equal. Am I right? That's why only one diagonal bisect the other. So in some quadrilaterals, the diagonals cut or bisect each other at 90 degrees or right angles. In a square, the diagonals bisect each other at right angles. Okay, right angles. In a parallelogram, the diagonals bisect each other, but not at right angles. Okay, so this side and this side may be equal, and this side and this side equal, but bisect each other, but not at right angles. So here we have, if you want, when you're watching the video lesson, please stop it and look carefully, okay? It's very important page, properties of quadrilaterals. Here is a summary of the properties of the special quadrilaterals that you should know. First one is, what kind of shape? It's of course, where's my pen? Square. All sides equal. All sides are equal to each other. All sides the same length, x centimeter, x centimeter, x, x. Okay, for example, 5, 5, 5, 5. And two pairs of parallel sides. This side to parallel this side, also this side parallel to this side. And all angles 90 degree. As you know, the interior angles of rectangle or square especially is equal to 360 degree. 4 times 90 is equal to 360 degrees. Diagonals that bisect each other at 90 degree. Okay, as you know here also 90 degree. 4 lines of symmetry is previous lesson. If you remember, we had to learn symmetry, lines of symmetry. What was lines of symmetry? If you divide it 4 equal parts, they will be equal to each other. For example, first of all, vertically, horizontally, second, and diagonal. This part and this part, when you close, when you fold it, they're equal to each other. Also, these diagonal lines, and we have 4 lines of symmetry in a square. Order 2, sorry, 4 rotational symmetry. What was the order rotational symmetry? It was when you turn 90 degree, 180 degree, and 270 degree, and the last one is 360 degree. When you rotate it, and the shape is not changing. That's why in a 360 degree we have 4 rotational symmetry. And else, as you see here, we have rectangle. Rectangle means not all sides are equal, but 2 pairs of sides equal their lengths, but their angles are equal, of course, each other, 90, 90, 90 degrees. And 2 pairs of parallel sides. 2 pairs of parallel sides. This side parallel to this side, and left side parallel to right side. All angles 90 degree. Diagonals that bisect each other, and the 2 lines of symmetry. 2 lines of symmetry. If you want, I will show you here, of course. First one is vertically. When you draw the vertically line, this part, when you close it, when you fold it, they are equal to each other. And also horizontal, when you draw the horizontal line, straight line, when you close that 2 parts, they are equal to exactly. So order 2 rotational symmetry. What was the order? One by one. For example, first of all, turn to 90 degree. Okay, if this our rectangle, when I turn to 90 degree, what's a new shape? New shape means like this, for example. A comes to below. Am I right? And after that, there's we haven't any similar shape because its height is very long than first shape. That's why they are not equal. But in 180 degree, it comes the same shape like this. Whereas A is comes to here, but their lengths and heights are equal to each other. That's why it's first. And third, the second one is 270 degree. When you rotate 270 degree, uh, A's come to here. Am I right? Or here? Okay, no problem. But not equal to first shape. That's why in the last one, 360, when you rotate to 360, it comes to itself. That's why in rectangle has got 2 lines of symmetry. Order of rotational symmetry. Sorry, order of rotational symmetry. 2 lines. A previous example I have showed you. I have showed you. And the others and rhombus. This diagram's name is called rhombus. Rhombus also 4 sides are equal to each other. All sides the same length, and you can read the properties. Okay, for example, 2 pairs of parallel sides, opposite angles equal, opposite angles. For example, this angle and this angle, this angle and this angle are equal to each other. Okay, and diagonals that bisect each other at 90 degree. 90 degree. diagonals bisect 90 degree. Two lines of symmetry, two lines of symmetry horizontally and vertically. Order of two rotational symmetry. When you return, when you turn it 180, you get the same shape. And again, when you rotate it 360 degree, you get the same shape, rhombus. And a fourth uh, shape is, as you know well, it's parallelogram. Two pairs of sides of equal length, this side and this side equal, and also this side and this side or heights are equal to each other, and two pairs of parallel sides, okay, opposite angles are equal. For example, this angle and this angle equal to each other. For example, 95, if it's also must be here 95. Am I right? And here also, for example, 85 must be equal to 85, or 70, 70. Don't forget these properties. Diagonals that bisect each other, of course. And order two rotational symmetry, it hasn't got, how can I say, symmetry lines. Okay, if you want to divide here, horizontal vertical line, this line and this line not equal. When you close it, when you fold it, you can take a not same shape. Okay, their size is not same, not equal to each other. And also, if you divide it with diagonal lines, this line and this pair, when you close it, when you fold it, as you see, will you see exactly they're not closing their pairs. That's why there's no lines of symmetry. But in order to rotational symmetry, it has got two order rotational symmetry. Okay, in 180 degree, and the second one is itself, of course, in 360 degree. And here also, where's my pen? What kind of shape? It's kite, of course, kite. Now, when I close these properties, can you tell me what it has got properties? What kind of properties it has got? Okay, please check yourself. Stop the video, and you can see, first of all, you can check yourself. Look carefully, and you can check yourself. Two pairs of equal sides. Two pairs of equal sides. Where's my, yes, here and here equal to each other, and also here and here lines are equal to each other. No parallel sides. They're not parallel. Okay, this means not parallel. It's only equal. In kite hasn't any parallel sides. Uh, one pair of equal angles. One pair of equal angles. Okay, which angles? It's here, here. The other angles are not equal to each other. One diagonal that's bisect the other. One diagonal bisect the other. Okay. How can I say? Yes, this diagonal bisect each other, and diagonals that cross at 90 degree, as you see, 90 degree. One line of symmetry. One line symmetry. What is the line? It's horizontal line. Sorry, vertical line. It's two equal parts. Order one rotational symmetry. When you return 360 degree, as you see, your shape will the same this shape. And trapezoid has sides of different lengths, one pair of parallel sides. This side and this lengths are parallel to each other. Okay, but their lengths is not equal. Also, these lengths are not equal to each other, and that's why I want to draw like this. There is three, and there is one. So, angles of different size, angles of different size, angles X, Y, Z, and T. No lines of symmetry, no lines of symmetry. Order one rotational symmetry. It is 360 degree or itself. Okay. An isosceles trapezium has, what does mean isosceles? Two sides are equal, and also two angles are equal, must be equal. And two sides the same length. One pair of parallel sides, of course, these sides, and two pairs of equal angles, this angle, and angles equal to each other. And one line of symmetry line is I mean, it is vertically. Yes. Order 1 rotational symmetry, it is, of course, in 360-degree. There's some questions. Before that questions, work the example we have. So let's read. I am a quadrilateral with no lines of symmetry. Hmm. Any sides? How can I say? It hasn't any symmetry lines. Which shape it was? If you remember, here we have no line symmetry. Here, no line symmetry. In trapezoid, in isosceles trapezoid, one line symmetry, and here also, yes, parallelogram has also, how can I say, no line symmetry, but parallelogram has, how can I say, two rotational symmetry, but here one rotational symmetry. If you read carefully the question, you will see, and my diagonals cross, but not at 90. Hmm, it's cross diagonal lines, but not 90. Okay. And our, how can I say, uh, parallelogram also not bisect in 90, and trapezium has also not 90-degree, their diagonal lines. Okay, let's continue. And they don't bisect each other. What shape am I? And they don't bisect each other. But here you will see, mm, where's diagonal lines? Each other, we have diagonal that bisect each other. Okay, and here there is no written, I mean, a diagonal not, how can I say, bisect each other. So what shape am I? Of course, trapezoid. Let's read the explanation. No lines of symmetry means that shape could be a parallelogram or trapezoid. Yes, okay, because in parallelogram and a trapezoid has no symmetry lines. The diagonals don't bisect each other means it's a trapezoid. Okay, in parallelogram, diagonals, of course, bisect each other. So there's we have 5 questions. I want to show you, I want to solve for you three questions, and others, please check yourself at home. First one, name each special quadrilateral being described. Okay, first one, A. All my sides are the same length. All sides are same. A, 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 A. Okay. My diagonals bisect each other at 90. Here, 90. Okay, I have 4 lines of symmetry. 4 lines of symmetry. In which figure we have 4 lines of symmetry? First, second, third, and fourth. It's of course square. It was square. Okay, so what shape am I? It's of course square. And a second, I have ordered 2 rotational symmetry. What's the rotational symmetry? When you turn 90, 180, and 360, and 270, but no lines of symmetry, it's of course parallelogram. It hasn't got any lines of symmetry, but it has 2 rotational symmetry. And I want to solve which one is, for example, E. I have one pair of parallel sides. I have ordered 1 rotational symmetry. I also have 1 line of symmetry. 1 line of symmetry. If you remember, it is an isosceles trapezoid because it has got only one symmetry line and only one, how can I say, order 1 rotational symmetry. And what is the question? What was the question? I have only one pair of parallel lines. Yes, it has got only one parallel lines, as you see. 1 minute. Okay, and so that's why it's isosceles trapezoid. So other B, C, it's for you. Not B, we have solved already. C, D, it's for you. Please check yourself at home. And the next question, where's our next question? We have finished, I think. Okay, please, if you have some questions, please write me and watch again the video lessons. Okay, stop the videos and careful lessons. If you have some question, you can send me by the page. See you later. Keep your healthy, my friends.